Alright, so last time we did the perimeter of, you know, two-dimensional shapes, basically 2D shapes. So now we're going to look at the area, and remember perimeter. Think fence, and for area, like what you are encompassing. So again, draw the fence. Right. So what's all inside of here? Looking at the area, and then the fencing is a perimeter. So basically, once we have the enclosure, we're just looking at, well, how much did we cover, and that's the area. And this is just memorizing formulas. So let's look at a rectangle. Let me go to a new one. Okay, so rectangle. Rectangle area. If we draw this, we know that this is length, width. It doesn't matter because this is a 2D shape, so interchangeable. Remember, so with the perimeter, we added. Right, because we were just looking at, how much fence do we need to do. Now we're looking at the inside, so each of these little blocks, right? So now when we look at the area, we're just going to multiply. So it'll be length. So length times width. That's the area. So if I gave you a rectangle, I said it's a rectangle. Say this was 5, we'll say meters. Just assume all meters, so I don't have to keep writing down. This is 10. So what is the area? Well, if we know our formula, it's just 5 times 10, right? And so this would be 50. Now, when we added meters, right? We were just looking at the length, so it was 1 meter plus 1 meter plus 1 meter, right? But now we're multiplying. So it's meters squared. So remember, it's not 50 meters, it's meters squared is the area, because you're looking at the entire square. Now, if I tell you a square, right, and I will say 5, right, so it's still the same as length times width, which is, 5 times 5, which is 25 meters squared. And some people would say there's a special formula where you just say it would be area would equal, side squared. This is just a side, right? So s squared, but you don't really need to know that because this is still a length and a width. So the same formula still applies, but because the sides are the same, you can reduce it to that. But you don't need to know this. Just remember it's length times width. And this applies to a four-sided, special case polygon, which is the rectangle and the square. So now let's go to just a regular parallelogram. And what I mean by regular parallelogram, these you'll notice are very interesting. So when we say parallelogram, it's because the lines are just parallel. They'll never meet. So again, we're just taking the base and the height, but you don't see the height here clearly. So what the area of the parallelogram is so we want to draw a straight line to always, we're always trying to find the height. We'll know what the length is usually, right? So, you can look at a parallelogram like this, which will end up being, these will end up being a right angled triangle. Or you can just do just the base times the height, because you get the same thing, because what you're doing is you're cutting a portion here, and then you're taking area 1, area 2, and area 3. And I'll show you how that works. So if I say that this is, this length from here to here is 12, and this height is 5. Height is 5, right? So I've already given it to you. So we can say that the area is 60 meters squared. But let's say I did not have the height that I was given. Let's see, this is 5. This is 4. Well, you'll get a different answer now. Okay, so, and then this will end up being 3. This is just, don't worry about it now, this is just a special case, a special rights rule. So if we do 3 times 12, right, in this case, so let me take this out, we'll get 36 meters, meters squared, right? And so that's just multiplying the length times the height. Now, let's just say I didn't do that. I wanted to actually, break this up and do it. Well, I can actually do that. So, because it's parallelogram, this triangle is going to be equal to this triangle. So then this is still going to be a 3, a 3, 4, 5 triangle. So you have 8, and so the center will be 4. So then just watch the beauty of this. So 3 times 4 is 12. You have another 12. And then, lo and behold, you have another 12. Hold on, something's... It's 36. So this is right, 4 times 3 is 12. So this is 4, 4, 4. Yeah, this is 3 times 4 is 12. 12 times 3, so 36. So actually something's not turning out right. I'll get into... Whoa, that didn't turn out right. Whoa, okay. Something didn't... Oh, what the hell? What happened here? Okay, let me see what happened here. Something weird happened with this pen. What is this doing? Okay, 1 second. Whoa, what's happening here? Something weird is happening here. Let me come back, because something is... Something weird's happening with this. Okay. Okay, what happened? Okay, I see what happened. Brush size, I guess ink flow should be. Let's see what happens here. Okay, that's fine. I don't know what happened. But okay, but so something here is not adding up. Uh 3, 4, 5. Yeah, that's fine. Height, so 12. So this is should be a 6, and this should be a 12. Uh, 12. Uh, let's see. So this is the height is 3, 4, 12. So this area would be a 6. This would be a 6. Okay, so this is 4. This is 4, 8. So yeah, this should be a 12. Oh, okay, so this is what I didn't do right. So this is actually an 8 right here, okay, because I drew it wrong, okay. So you block off one end, so yeah. So this is at 8 times 3, which is a 24. And now you're getting a 36, which equals the same as the height, which is, if I did 12 times 3 times 3, it would be 36. Perfect. Okay. So we covered that. We covered the parallelograms. So now we're going to end with the triangles. And so I just did the triangle first. So basically the triangle, I'll just do in a nutshell. Triangle is half the base times the height. You know, you could do length times width, half as well. And why is it half? Well, let's look at a square. What happens when you cut it in half? Triangle 1, triangle 2, that's where the half comes from. No need to, make it more complicated than it is. Now, you can get very, very creative with the triangles. So you could have, isosceles, acute, obtuse. But remember, if it's not a right angle triangle, whoops. See, so then this would be the height, the width, and so you don't have to solve for it. Now it gets complicated when you start having, this junk right here. So usually you'll be wanting to find the area of the entire triangle, even with the height. So if we had, 4 and we had 15. Well, we're going to be missing, the entire base is 15. and we have the height here, we're going to be missing a couple of things. So well, we want to know the area of this portion, right? So if we have the area of this portion being 3, then this area would be 12. And, we kind of just basically, you know, essentially, solved for this, right? So when we look at it, so we could say 4 times 15 is 60, and this would be meters squared because we're always in meters. But that's essentially it. So yeah, take care.